Alright, so today we'll be working on a second grade addition problem with double digits. First, let's read our question. We have a word problem. It says, Katie is baking cookies for her grade for their Valentine's Day party. She has already baked 26 cookies and still needs to bake 37 more. How many cookies will she have when she is done baking for the Valentine's Day party? Today we will be solving this problem by using the place value approach and set model. So first, let's look and to see what our question is asking us. So it says that she already baked 26 cookies right here, and she still needs to bake 37 more. So we need to add 26 plus 37. Let's look at this in an abstract way. So we said that we need to add 26 plus 37. So what do we know about 26? We know, and like I said, this is our abstract way of looking at this. So 26, we know that you have 2 tens plus 6 ones. Alright, and then for 37, that breaks down into 3 tens and 7 ones. So as I mentioned earlier, we're going to be using the place value approach to solve this question. So let's bring in our chart. We'll be using base 10 blocks, which is a concrete method of working through this problem. So as we said, in our abstract model, we have 26, which is shown through 2 rods, each consisting of 10 units, and 6 ones. So 1, 2, 3, 4, 5, 6. Alright. Then we need to add 37, which consists of 3 tens, and as we said, each rod consists of 10 units. So 3 tens and 7 ones. 1, 2, 3, 4, 5, 6, 7. So let's see what our answer is. We have 1, 2, 3, 4, 5 tens, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So, as I mentioned earlier, each rod consists of 10 units. But over here, when we were counting to find our answer, there were 13 one blocks. So that means we need to regroup. So let's take 10 of these squares and regroup them into a rod. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these 10 blocks will be regrouped into a rod in the tens category. Alright, so now let's count to see our answer. We have 1, 2, 3, 4, 5, 6 tens, and by subitizing we can tell there are 3 ones, 3 blocks in the ones category. So overall our answer is 63. So let's come back to our abstract chart, and we can now say with confidence that 26 plus 37 is 63. Alright. Alright, today we will be working on a 3rd grade elapsed time problem that transitions from AM to PM. Our question states, Alberto is so excited that it is field day at his school. He is most excited for the relay race. If it is currently 10:30 a.m. and the relay race starts at 2:15 p.m., How much time does Alberto have to wait until the relay race begins? So first, let's take a look at an abstract representation of our problem. Alright, so on the left, we have a clock that shows 10:30 a.m. with the hour hand pointing towards the 10 and the minutes hand pointing towards the 6 to represent 30 minutes. This is our start time. On the right, we have a clock that shows 2:15 p.m. with the hour hand pointing towards the 2 and the minutes hand pointing towards the 3, which represents 15 minutes. This is our end time. Our question is asking us, how long does it take to get from 10:30 a.m. to 2:15 p.m.? We can see this visually through the linear model, and as I said, we'll solve this problem with a linear model using the number line approach. So here is our linear model. Now, what I have done is I have put the 10:30 a.m. as our start time, as we said, and 2:15 is our end time. But as you can see, the arrows still continue, so that doesn't mean, that's not the only time that exists. That's just what we'll be looking at today. Also, one thing that I've done is, if you notice, I have small notches on my number line. These represent hours. The reason why I did this is because on a number line, it's very important to be specific. That way, when you're measuring, it can be very clear. So, for example, I did by hours: 10:30, 11:30, 1:30, 2:30, or 1:30 and 2:30 here. So 2:15 isn't quite there, but it's close. Okay, so first what we're going to do is take a small jump to get to a more familiar number. So our first jump will go from 10:30 to 11, and as I said, this represents 11:30. So we want to go right in the middle, and this is plus 30 minutes, and it gets us to 11 o'clock. Then we're going to take another jump, and the easiest number is an hour. So we're going to jump an hour. So we have plus 1 hour, which gets us to 12. This is AM, and this takes us to 12 p.m. So as we're transitioning into p.m. on the next jump, it's important to remember that after 12 p.m. comes 1 p.m. So because of the base 60 system, we don't go to 13, we go to 1 p.m. So we'll take another hour jump, and we'll get to 1 p.m. And then we'll take another hour jump, which will take us to 2 p.m. And finally, we just have a small 15-minute jump. That brings us to our final place, which is 2:15 p.m. And it is very important that you note your AMs and PMs, because as you can see right here, we transition from AM to PM. Alright, so now to figure out how much time actually has elapsed from 10:30 to 2:15, we need to add up these numbers. So first, to get from 10:30 to 11, we had 30 minutes. And then to get to the next, we had an hour. We jumped another hour. We jumped another hour. And finally, we did a small 15-minute jump. So if we add these up, we can see 0 plus 0 plus 0 plus 0 plus 5 is 5. 3 plus 0 plus 0 plus 0 plus 1 is 4. And 0 plus 1 plus 1 plus 1 plus 0 is 3. So, from 10:30 to 2:15, it took us 3 hours and 45 minutes. So, you can use this timeline, this number line, or more commonly known as the linear model, to help you with those little jumps so it's more comfortable. All right, there we go.